When someone is in need of money, they either go to bank or they go to lenders who can give them money. But when they're giving money, they gotta make sure that some customers return the money back as well. So how do they determine that? It is determined using credit score. Good morning, everybody, and thank you for joining me today. Today, we'll be diving into the world of credit scores, a concept that affects not just individual financial opportunities, but also the stability of a broader economy. The agendas of today's project is going to be we're going to go through the overview of a project, then we will cover the problem statement and objective, then followed by data set overview, then modeling and results, then conclusion, and finally, future work. So, what are credit scores? Simply put, they are numerical representations of an individual's financial health. Credit scores helps lenders, businesses, and even landlords assess whether someone is likely to repay a loan or meet financial commitments. Think of a credit score as a snapshot of your creditworthiness, a number that speaks for you when you apply for a loan or make a significant financial decision. So, what factors contribute to the score? Well, there are a few critical ones. First would be the payment history. Do you pay your bills on time? This is really important as if you don't pay your bills on time, the lender is going to believe that you're not going to pay his money on time. Second would be credit utilization, where how much of your available credit are you using? Because if you keep maxing out your credit, it means that you don't know how to manage your money. Third would be length of the credit history. How long have you been building credit? So the longer you build, the better it is for you. So people can trust you because they know how you handle with money. Fourth would be diversity of credit accounts. Do you have a mix of credit cards, loans, and other accounts? Because this will help understand what kind of a person is this and how is he trying to handle his money. And finally, number of recent credit inquiries. Have you applied for new credit card recently? So all these come into picture when you're trying to get a good credit score. So beyond this personal implication, credit score plays a pivotal role in the economy. They guide lenders in making informed decisions, influence interest rates for borrowers, and help financial institutes manage risk. In essence, they are an indispensable tool for ensuring stability in financial transactions. However, despite these importance, the traditional systems used to calculate credit scores have significant limitations. That's where my project comes in today. Today, I'll walk you through how my machine learning models can make credit score systems more accurate, fair, and insightful. So, to set the stage, let's explore the challenges with traditional scoring systems and what motivated this research. First, the problem. Traditional credit scoring relies heavily on historical financial data, like past loans, credit card payments, or debt levels. While the data is important, it can often misrepresent an individual's current financial status. For example, someone who recently improved their financial habits may still face lower scores due to past issues. Moreover, these systems tend to exclude alternative data sources such as rent, utility payment. These omissions disproportionately affect certain groups, especially those without access to formal credit systems, potentially leading to bias and inequitable distance. This is a problem not just for individuals, but also for institutes that manage the missed opportunity to lend to reliable borrowers. So, what is our objective? What do we plan to achieve? Our primary objective was to develop a robust credit score classification system that addresses these gaps. To enhance prediction accuracy, we leveraged advanced machine learning algorithms, including ensemble methods like random forest and XGBoost. We also aim to incorporate diverse data sources to create more comprehensive picture of creditworthiness. Lastly, a key focus was to analyze and mitigate bias inherent in traditional models to ensure fairness outcomes. The ultimate goal, a system that doesn't classify credit score better but also empowers individuals to take charge of their financial health. Imagine a world where credit scores are not only accurate but also equitable, making financial opportunities more accessible for everyone. So, keeping this in mind, this is the data set I have collected. Our project relied on robust data set to make this vision a reality. I outsourced the primary data from Kaggle, which contained real-world financial data such as credit history, payment behavior, and other personal financial attributes. So When I went through the data, I figured that there was not sufficient data, due to which I made an API call for unemployment data because I realized that unemployment data is going to be a huge part in determining whether somebody gets a good credit score or a bad credit score. For this, I had to capture the macroeconomic trend to receive historical unemployment data using the Federal Reserve Economic Data API. This data was pre-processed and prepared for machine learning. Without diving into technicalities of data cleaning, it's worth noting that combining individual and economic factors allowed us to develop a more holistic and insightful model. This is how the model looked before we pre-processed the data. So if you can have a look at the left side of the screen, you would also notice that like in the columns such as monthly in-hand salary, there are NAN values, and there were many such other columns. But after pre-processing, the data was pretty much clean with no missing values and no outliers, which was ready to be fed to the model. Now, let's get into the core of the project, our findings. To classify credit score, we tested several machine learning models. Each offered unique insights and performance results. So I performed unsupervised and supervised learning for this project, where in unsupervised, I used principal component analysis, clustering, where in clustering, I had used hierarchical clustering, k-means, and db-scan. Apart from this, I also used association rule mining to find if I could figure out some new insights from the pattern, which could be used in my other models as well. I use five supervised models over here. First one is naive bias. Second is decision tree. Third is regression, which is about logistic regression. Fourth is support vector machine. And fifth is ensemble methods, which include random forest, XGBoost, and AdaBoost. Now that we are now going to dive into each model, I will be going through some of the results of the most effective and intriguing models. So let's start off with random forest. So my random forest model gave an accuracy of 94.73%, which is pretty impressive. But it is something I also speculated, as random forest is a model which tries to fit the data as well as possible, making many branches as it should. But this model was created to limit the number of branches it has, the level of tree, in order to not overfit the data. And this was a more generalized model, which led to this kind of an accuracy. I also observed that while binning the data, I also tried running the model with bin data and it reduced the accuracy. So by this, I actually learned that accuracy is affected by binning as it is losing some essential information, which it could capture on its own. And the most important features in the data set are credit mix, outstanding debt, and interest rate. This was a pretty interesting finding for me, something which is already understood by all of us, but something which you could find from the model, which could help us understand more about why or how the model is going to classify. Now let's go to the next model, which is logistic regression. So in logistic regression, surprisingly for binary classification, logistic regression outperformed expectations with an accuracy of 97.41%. This was done using just a binary classification, as I mentioned, which was for a label good and bad. The data set which I had three labels, which was good, standard, and bad. And to check how efficiently the model is working, I also used multinomial naive Bayes, which tested with the binary labels, yielding an accuracy of 89.55%. This marked an improvement compared to the 80% accuracy observed in the three-class problem, highlighting some features overlap, making multi-class classification more challenging. So from this, I could realize that the standard class was having values in all the features which were lying in between good and bad, making it more difficult for model to classify. So next, let's get into the SVM model. In SVM model, using a linear kernel with a hyperparameter c is equal to 0.1, we achieved an accuracy of 77.84%, while an SVM model with a radial bias function, basis function, kernel with c is equal to 10 achieved a higher accuracy of 90.5%. This demonstrated the importance of proper hyperparameter tuning for improving the model's accuracy. As you can look on the screen that I have put this confusion matrix for SVM with linear kernel as well as for RBF kernel. And we can see that the class good, there's a drastic improvement in the classification of it with lesser number of misclassification for other labels. Finally, some of the interesting findings were found in ensemble model where I got an accuracy of 96.6% for random forest, which is a bagging method, and accuracy of 92.91%, which is close to 93% for XGBoost, which is a boosting method. So you can see the confusion matrix over there and see that the model predicted pretty good for multi-class label. And it was helpful to understand that, particularly in cases with subtle patterns in the data. Another fascinating aspect of the project was identifying the most influential factors in credit scoring. Like I mentioned earlier, using random forest, credit mix, outstanding debt, and interest rates emerge as the top features. These findings underscore the importance of a nuanced evaluation of creditworthiness beyond just repayment history. Our results not only validate the potential of machine learning in the domain, but also provided actionable insights for improving existing credit valuation system. Now, let's come to the conclusion. Uh, our project successfully demonstrated that machine learning can enhance credit score classification in a meaningful way by leveraging advanced techniques and diverse data sources. We achieved a high prediction accuracy model across multiple layers, a deeper understanding of the factors that truly influence creditworthiness, and a framework for addressing bias and inequalities in the traditional system. From a practical perspective, this means financial institutes should use such models to make more informed lending decisions, reducing risk while opening doors for unserved population. For individuals, this system provided clear insights into what impacts their credit score, enabling them to make better financial decisions. Looking ahead, I have few future work recommendations. One is incorporation of additional features. Include alternative data sources like rental payment history and utility bills to improve model comprehensiveness. Second is real-time data integration. Use dynamic data such as live economic indicators for real-time credit score prediction. Third is personalized recommendation. Provide actionable insights for individuals to improve their credit score based on models output. Fourth is multi-class model improvement, where we explore advanced techniques to handle features overlap, as I discussed earlier with few of the models, and improve multi-class classification accuracy. Fifth would be explainability and transparency. Develop interpretable models to ensure stakeholders can understand and trust the predictions. And finally, bias mitigation. Investigate and address potential biases in the dataset to ensure fair and equitable credit assessment. In conclusion, the future of credit scoring lies in the intersection of data, technology, and fairness. By rethinking traditional approaches, we can create systems that are not only more accurate, but also more inclusive. Thank you.